Nick, Jan and Lars for their upcoming presentations. For today, the agenda is already set, but feel free to let us know which topics you would like to see covered in future sessions. The topics of today are how templating can be used to maintain multiple pipelines by Nick Rabai from Mediahuis, of course. Then some example pipeline of building Docker containers within a Kubernetes cluster with Podman, and Docker in Docker by Jan David, also a colleague of us at Mediahuis. And then two demos by Lars Blokken, a solution architect of GitLab, about auto DevOps on AKS and advanced CI/CD best practices. We try to reserve some time for questions at the end of the session. So, okay, let's start it. Let's get started. Nick, over to you. Nick, we don't hear you. You are muted.
Yes, sorry. Welcome, everybody. I'm glad we have the opportunity to show some of the stuff we have been working on with Sam and Geoffrey and Ordina, our partner that helped us set up a first version of reusability in GitLab for using pipelines. So why did we do this? Because we see that a lot of our teams are actually reinventing the wheel all the time. And that's the quality difference between teams on how to build and deploy using GitLab. So we thought this can be improved. And we went to the partner Ordina, who had a lot of experience using these reusable components. So I will show you today what we did and what the next phases will be. So we wanted to increase on reusability, standardization, performance, and also best practices around security scanning, vulnerability scanning in the pipeline themselves. For this, we did some assumptions. One of the assumptions that Ordina made that we think was very, very useful is that we wanted to do some kind of automatic versioning and release tagging and release nodes generation. And for that, we had to come to some agreements. Nope. Is there a problem? Because I don't.
Yeah.
Okay. I see some activity, but I'm not sure what's happening.
I muted some people.
Okay, thank you. And Ordina came with the idea of implementing conventional commits and semantic release. And this helps us with a lot of things. It's actually a very easy concept. So every time you do a commit, you use one of these prefixes. And this will allow GitLab, or the semantic release component of that we introduced in GitLab, to automatically calculate version numbers. So if your commit contains just some documentation update, you prefix the commit with docs, and you just say added a comment or updated user documentation. This will not create an upgrade in the major version number or the minor version number, and this will be a patch release. This will change the last version number. And these tags will be used in every other aspect of the build and deploy flow. To tag the Helm chart, for example, to tag the container image. And it will also automatically generate the release notes. One of the nice things, if you introduce a breaking change, you just add an exclamation mark, like the last line, if you see it, fix, exclamation mark, features, exclamation mark. Just by adding the exclamation mark, the semantic release component knows, hey, this is breaking change. I have to update the major version number. I will show you in the demo how this works in practice. So the benefits of using these conventional commits and these semantic releases, that it automatically creates a standardized way of working across teams, and also that a lot of things can be automated. Second component that we did was, of course, a pipeline templates, but we wanted to build something that is highly scalable, and when we introduce changes to the templates, that it's automatically propagated across all the teams that are using these templates. Somebody says I have to speak Dutch. I don't know why. There are some people from GitLab that are speaking English. Nick.
Maar het zou ook in het Nederlands kunnen, als je dat voor jullie makkelijk is.
No, because we have some people that will see the recording, and they are also possibly.
Yeah, we're
so
okay.
European company, so if we share the recording, it's better it's in English.
But thanks.
So how this works is there's a dependency bot that's actually a scheduled job that we implemented that scans the templates for changes and all the teams projects that are using these templates. And as soon there's a change detected, it will automatically create merge requests to each team. Hey, there's a new version of your template. These are the changes. Do you want to import the changes? For example, there's some dependency on a library that got updated, or there's some improvement in the security scanning job, or we switch to another security scanning engine, or we introduce a load test. And this will allow one team to focus on improving these templates and other teams just to consume the changes. So here is an example of such a dependency dashboard where you can see all the dependencies. And as soon as somebody changes something in your project, you will get a merge request, update to templates, Node.js, for example, and you can easily inherit these things. So enough slides. I will show the demo about these things. So if a new team or a new development of an application starts, they can just start new projects. And here's a button that not a lot of people have used in the past, I think. It was also new to me. Now it's possible to say create from template, and you have some different templates that GitLab has incorporated into the product. But we also added instance level templates that are Mediahuis templates built by Ordina that are specific for our needs. For the things that we find important that every template has to contain are incorporated in here. For example, if I want to build a Node.js application, demo 2, I can just say, I want to start building a Node.js application. I will just consume this template. So what it does now, it populates my project with all the things that we already pre-configured for the team. So the only thing that now has to happen to make this work, we have put in an example CI file. So I will rename it. So next time we commit to the GitLab, this will automatically be triggered. And here in the SRC folder, you have the application itself. We provide just a simple hello world, so that as soon as you commit the change to the CI file, it will automatically build something working. Yeah. So
there's a extra dot in your GitLab CI file. The last one you did.
Okay, that's a good thing that you. Thank you. Thank you for. Okay. So I was showing you the source file. Okay, so now if we commit, this will actually build this Node.js project. And as we have seen briefly previously, if I use these conventional commit syntax, and this will be also checked on every commit, by the way, this will make sure that all the release nodes are automatically generated, that the build number is actually provisioned automatically. So if you now go to the project, to the pipeline, you will see it starts running. So that's how easy it is to start building a new application based on the template that we've built. It will automatically detect if there are secrets in your code, like password, tokens, etc. It will build your app. It will scan the container for vulnerabilities. It will do some assessments that we can extend, and then it will create a release. So, and this is how we will introduce new best practices in the template. It will take some time, but I already have created a prepared demo because I don't want to wait for the build, because my colleagues that I have to present will also need some time. So here I have some examples. This is my initial version. So I did a commit. It did a build of all these steps. And here in the last step, for example, you will see that semantic release is looking at all the commits that happened, and it will generate a version. If I go back and look at another commit, for example, here I introduced an exclamation mark, fix exclamation mark, adding 2 more messages. So if you go to the release, you will see that it upgraded automatically to a major release, a bumped to a major release version. What these pipelines also do at the moment, if you go to the package registry, they will automatically push Helm charts. So your application is easily deployable. It will also automatically push container images and tag them with the release tags. It will, for every major version, it will tag it. It will also do it for the minor version, and it will do it for the full version. Every time, automatically, out of the box. This is just a first iteration of these templates that we're building, and there's additional work to be done. So we welcome your input if you have ideas on what we have to add. Like in the second phase, we will focus on blue-green deploys, for example, on the customize and Helm integration, on changing to the new way of building Docker and Docker builds, depending if it's Podman or using the Docker builds tweaks that Jan David from our team came up with. But it's in the second part of the presentation. Jan David will tell us something more about this. So now I will give the presentation to Jan.
Okay, thank you very much, Nick. I guess I need to share my screen.
Yes, please.
Right.
And finally, you can see who is in the presentation. Welcome, Cora and Ingrid.
Okay. Okay, almost there. Yeah, this should be it. Is it visible for everyone?
Yes, Jan.
Okay.
Yeah.
So
maybe just a presenter mode or a slideshow.
Yes.
Thank you.
All right. So a small introduction. It's a lot of text, but I'll run it by you quickly. So at the moment, we still have dedicated virtual machines that are basically GitLab runners that take workloads and process jobs for developers. But as we tend to move more and more things to the cloud, or at least to Kubernetes managed containers, one of the things that we want to reduce is like maintenance of dedicated virtual machines. This means that the built machines that we now have and that use where Docker is installed so people can build Docker containers, we will be getting rid of them. So how do people need to build containers? Basically, you need to do some sort of Docker in Docker, because in Kubernetes, of course, everything that runs is in a pod, which is one or more containers. So if you want to build something with Docker, you have to run Docker commands in a container, basically known as Docker in Docker. And there are a few options to do this, and I'd like to discuss them in the following 10 minutes with you. So you can do actual Docker in Docker, meaning the actual Docker well-known program, and run it in a Docker container. But there's also an alternative called Podman, which is, if I'm not mistaken, a product from Red Hat, and I believe it's used in their OpenShift product. There's also another option called Canico. And then finally, I would like to have a quick word of what we prefer or what we'd like to go forward with here at Mediahuis. So first off, Docker in Docker. As the advantages, it's well known. It's the standard, it's the default. Another plus, I think, is that you can do multi-architecture build with it. Maybe not something that a lot of developers are using at the moment, but in the, let's say, more distant future, we are also looking at using AWS Graviton servers or instances to run our workloads on, because they offer better performance and are cheaper. So the disadvantage is that you're running on ARM64 architectures and not Intel. So we're starting to build more and more images and containers in a multi-architecture way, meaning you have you only have one image in the repository, but actually consists of two images or more, being like an Intel one, an ARM one, and even something else if you want. That's something that's fairly easy to do with Docker. The disadvantage of Docker in Docker is that it always needs a socket to communicate. And another disadvantage is that between different versions, well, I said different versions of GitLab, but it's actually different versions of Docker, it tends to break. And there always like a clutch you have to use to get it to work, which is not very comforting. So let's have a look at the examples. So if you look at this CI file, you can see that we start a service here, the Docker in Docker service. And then one of the tweaks we have to do, at least for the moment, is to add this command TLS false, and then also these variables where you specify the Docker host as local host and then the port number. This was in the previous version, this was something else to get it to work. And it's not guaranteed that when a newer version comes out, for instance, there is now the 24 release, and I've already noticed some issues with the 24 release. So it works for now, but unfortunately, it doesn't feel like it's very stable between versions of Docker, unfortunately. But basically, that's the way you can do a Docker build. You log into you do a Docker build, and it will contact its service via the service that you defined, and then Docker can build your image for you. Okay. Now a big plus, as I mentioned, are the multi-architecture builds, which are really easy to do with Docker in Docker. For instance, here we have an example of well, I thought, let's see, yeah, here. So basically, It used to be a separate command, buildx, but in the newer versions of Docker, so starting with 23 and further on, buildx and build are now the same. So you don't have to specify buildx, and you can just type build if you want to. And you specify a number of platforms, like in this case, Linux AMD 64 and Linux ARM 64. That's it. You don't have to do anything else, and it will build 2 images for you. It will build the ARM one and the Intel one, and it will push it. If you do a push command, it will push it to your registry as 1 image, but underneath are actually 2 or more images for each architecture one. Very easy and very useful, I think, in going forward at Mediahuis, because of the interesting price difference between so-called AWS Graviton instances, which are ARMS based, and the more classical Intel based, which are more expensive and offer less performance. So what's an alternative? I already mentioned Podman. Does not require a socket. It has a syntax which is for the most part compatible with Docker, which is very useful. So if you want to change like a GitLab CI file from Docker to Podman, you only have to do a search and replace of Docker and change the word Docker to Podman, and it should work. It also, at the moment, it's configured to use our in-house registry cache, which avoid the problem that some of our developers have already encountered, which is API rate limiting when you try to pull images from Docker Hub. Now, we could do the same thing for the Docker image as well, but at the moment we haven't done so. But this is something we could do for Docker as well. As a disadvantage, multi-architecture builds are possible using the Builda backend. So it's actually like a different tool you need to use, and it's a lot more complex. So let me give an example of Podman. As you can see, the commands are exactly the same. Instead of Docker login, you do Podman login. Instead of Docker build, you do Podman build. Instead of Docker push, you do Podman push. So exactly the same commands. So that's very useful. It's not like you have to relearn something. But if you want to do a multi-architecture build, it looks more something like this. You have to create a manifest, you have to do a build, and then you have to push that manifest. It's more involved, definitely, as you can see. It's not just as simple as specifying 1 or more platforms. So that's a disadvantage. And then finally, there's a third option that is used in a few rare occasions, which is called Canico. It also doesn't use a socket. It also is set up to use the in-house registry cache, so that's good. But there's, as far as I know, no multi-architecture builds, and the syntax is completely incompatible with Docker. And it is rather slow compared to the other ones. So if we have a look at how Canico looks, it looks more something like this, as you can see, with a different syntax and different keywords. So I'm not saying it's maybe not, it's usable, but it's yet another thing, yet another tool you have to learn. And I think most people will agree that we have plenty of tools already at Mediahuis. So if you look at the speed, I did a small test. And if you can see that for the same, this was this, of course, the same project that they were executing. Docker in Docker took about 90 seconds to do it. Podman about 86 seconds, and Canico about 138 seconds. So Canico is definitely a lot slower. The difference between Podman and Docker in Docker is not very well represented here, because the creation of the service, as I mentioned, you have to create a service where it runs Docker, and then you can talk to that Docker host. That takes a while. So the difference in speed between Podman and Docker in Docker will diminish if you have like a serious build project. If you have a build that takes several minutes, then the initial startup of the service will not be a big factor anymore. And then in that case, actually, we have reports of developers saying that Docker in Docker is a lot faster. So your mileage may vary. So conclusion, Kaniko, I think, was an interesting experiment, but doesn't bring a lot of benefits going forward. So as far as I'm concerned, I don't see it being used much more in the future. Podman is a solid alternative. Multi-architecture builds are a bit cumbersome, but it's fast and it can use the cache. So I think this is definitely something we will continue to use. Docker in Docker is used right now. And as I said, it has a few good advantages, such as these very easy multi-architecture builds. But then the stability of being able to use it in GitLab is a source of concern. It didn't work for a while, or it did work. You had to use a specific version 19.03, or lately it worked again with the very latest version. But then recently I tried version 24, which is the very latest one, and it seemed to have issues again. So that makes it, in my opinion, Podman is the safest bet to go right now. And if you want to do multi-architecture builds, maybe it's just worthwhile learning the build-as syntax, although it's a lot complexer. So for now, we're going with Podman and Docker in Docker, and we'll see what the future brings. That's it for me. Thank you very much for listening. I guess questions come at the end of the presentation. I don't have a demo. So next one is someone from GitLab, I think.
Yeah, me. Thank you, Jan. All right. Thanks, everyone, for giving me the time to present here today. My name is Lars. I'm a solutions architect at GitLab, and today I'm going to present to you a feature which we call Auto DevOps. It's going to be interesting, and especially because of the two presentations that were beforehand, it's hard to beat those interesting presentations. What I will try to focus on is how Auto DevOps can potentially complement the features that we've seen today. Then once I've explained to you how Auto DevOps works and what it actually does, we'll see how we can, as the name says, it's auto. We are going to make some decisions for you, how you can influence those decisions, and in the end, then maybe flow into a more customized pipeline. So the first thing what I'm going to do is share my screen, of course, and show you how it looks like within GitLab. Now, I've prepared a small example here. We're going to focus on EKS for now. So basically deploying to a Kubernetes cluster. I will first show you here the application, how it looks like for a developer once everything is configured. And then afterwards, I will show you how it basically looks like in the backend, how we come to this point, and then more and more going to more of an advanced setup of CI with self-made pipelines and what type of options we have there. So the first thing that I have here set up is a couple of projects to set up my infrastructure and set up my Kubernetes cluster, for example, here in the top. I've also set up some management for my EKS cluster, which I will also show you, because we can approach that with a GitOps approach if we wanted to. But the one that I want to talk about right now is this project over here, which is a simple Node.js project that I've imported, nothing special about it. One thing to keep in mind here is that there is no GitLab CI file. So I haven't configured a configuration for CI. And for the function of Auto DevOps, you actually don't have to. As a developer, what I can do is still, like normal, I would create my issues or use whatever system you use for issues, start with my merge request, and I would write my code. No difference there. In my merge request, however, there's going to be some cool information that we can use, and also the pipeline that we automatically kick off. Now, the first thing I want to talk about is that pipeline that we actually generate. So if I go into my pipeline here, and as I mentioned, I have not configured anything for it. We do basically, when Auto DevOps is enabled, we include a template that will automatically check what language is potentially being used here, and what can we do with that language, and how can we build it. So the first thing that AutoDevOps noticed in my project is I have a Docker file. Docker file has to be built. First step that it does here, builds a Docker container, throws it in the registry. Step one, done, great. Then of course, we want to test some of our applications. A couple of these scans are ultimate. I don't want to dive too deep in the different scans that we have here, but we have an automatic test stage that we build up. We do our security scans in there, your SaaS scanning can happen in there, your container scanning can happen in there, and then your unit tests, for example. We automatically detect if there's a unit test framework being used, and we will include those in the test stage as well. One of the features that I want to highlight here is that we have a review stage. And this is where I mentioned before that we're talking about EKS here. I will dive deeper in that as well at a later point. We are going to deploy this application to that EKS cluster so that I, as a developer, can have a very short feedback loop. I can see the changes that I'm making, but it also allows me to do a couple of other things. We can do more security scans, one of the benefits, because we have a live environment, shifting left, making all of those changes and making all those scans happen immediately. But we can also do things like it's a live environment. So if we want to run a test, for example, if you want to run Selenium tests or basically anything that you want to run on an active application, we can build that in the pipeline. Now, in AutoDevOps, what we do, of course, is we have those specific steps here. And one of them is that we scan for dust. And the other one is that we scan for performance. When we see that it's a web application, in my case, a JavaScript application, we actually then use browser performance or our browser performance test. If we notice that it's an API, we do a load test. And the load test is then going to be a bit more simple, what it does, but we can still compare performance between the default branch, for example, and here my feature branch. The last one that we see here is I have my review environment set up. And of course, this is going to, if there's an active development happening on the cluster, and for each feature branch, we want to create this review environment, we're going to end up with a lot of environments running in that cluster. To make sure that we also stop them, we make sure that we have this last stage there in the merge request or in the pipeline, that we can stop the review environment manually. If you would like to, we can come in here and actually stop the environment. I will show you in a bit how in the merge request we can do the same thing. But if we forget and we close the merge request, this pipeline will be cleaned up and it will also clean up that environment for you. So basically, we make sure that the environments are cleaned up afterwards. Okay. Going back to that merge request that I just showed you, as I mentioned, we had that review environment. Review environments, for me as a developer, I want to focus on my merge request. I want to not context switch too much. So in our case, we have here that review environment that I just deployed. And if I click on it, we can basically then see that I automatically get brought into my Kubernetes cluster. How it's all set up, I will show you in a bit, how we can configure it, how we come to this point. What important here is to know is that by configuring it once, so that means that in the system on group level, we have to make a configuration for the full group, then automatically all projects underneath can benefit from these features. Makes it a lot easier, of course, to use CI pipelines, because as I mentioned, you don't have to write any file. You don't have to start with a template. You can, of course, use your templates. As Nick showed, there's a lot of great templates available. But in our case, this is AutoDevOps allowing you to have a very easy step into building CI pipelines and having those review environments. Everything that you see in an AutoDevOps pipeline is also something that you can use. What I mean with that is you don't have to stay with AutoDevOps pipelines. You can actually evolve into your own pipelines and still use features of different functions that we have in there. How we do that, I will show you in a bit as well. So I said, this is how basically AutoDevOps works and how easy it is to use. As a developer, I don't have to do anything, right? On the back end, there's a couple of things that we have to do. So I've prepared a small markdown here is basically what we need, what we can do, and just for you to get that details on how clusters are basically being set up. So what we need is a Kubernetes cluster, as I mentioned before. This can be, in your case, EKS, can be another flavor, can be OpenShift on-prem, can be Rancher, but even Rancher Desktop or it can be even Docker desktop. For example, I have on my Docker desktop Kubernetes agent installed, and I can deploy directly to my machine from any project, basically, helping me basically to have an easier way to debug, but also I don't have to wait for or have to have a Kubernetes cluster somewhere in the cloud. It can run on my local machine. I can use that as well for my workloads. We have a function, or we have a product or an application basically called the Kubernetes agent. The Kubernetes agent we're going to install on the cluster, which I've already done in my case. And this Kubernetes agent does have a version requirement. So any Kubernetes version 1.24 until 1.26 we support. We always normally have like the normal release channels from for Kubernetes, which is stable, and then the one before and the one after, basically. What we also need is an ingress controller. Now, it might go a bit technical on the Kubernetes side, but I promise that we won't go too deep into it. But what we need is an ingress controller. We will be using the ingress Nginx controller. Don't have to use it. You basically just need to have an ingress controller that can open up the different services that we're going to create with these review environments. We also need, of course, a domain name that's behind it some way that we can access it, a wildcard domain in that case, or has to configure in such a way that the load balancer understands this is a wildcard. And then we can basically access all those different review environments. A couple of other things that I will show you as well is how to configure that Kubernetes agent. As in, we are going to configure that agent on the GitLab side. It's not something that you do on the cluster side. You basically add it once, and then afterwards configure the configuration through a GitOps approach. A couple of things that we do need is some environment variables, which I will also show you in a bit, to then configure. And then once we have all of that set up, we can access the Kubernetes agent and make this all work. So I'll just move this here to the side. Make this a bit that. And basically show you a little bit more on how that looks like on our end. So I mentioned before that I have here in this group a couple of projects and subgroups where I create my infrastructure. One of them is that I actually create with Terraform my EKS cluster. Less important how Terraform does it. What it is for us important though is that GitLab agent that we have installed. This agent lives in the Kubernetes cluster and is basically building for us a bridge between Kubernetes and the Kubernetes API and GitLab, the GitLab instance, and also access to Git and the package registry, for example. In this config file, what I've currently done here is I've created what we call a CI access. I'm allowing a specific group to access my cluster. And in this case, I've allowed the full Mediahuis group underneath my top level group to have access to this cluster. And by allowing this, I can select a Kubernetes context in my pipelines and push all of my projects in there if I wanted to. That is, of course, necessary for our auto DevOps function, but we can also use that for others. So we can actually set up the same way our Kubernetes agent and then use that to deploy regular applications through normal deploy steps. It doesn't have to be auto DevOps. Once this is all configured, as I mentioned, we need to set up some variables. What I've done here in my case to make it easy is under the Mediahuis group, I have set up under CI/CD my variables that are basically going to have my kube context and my ingress domain. And for my ingress domain, I've just taken my load balancer, my ingress that I've created. I've taken the public IP address of it and I'm using nip.io. You could, of course, set up a domain name that then refers to the IP address of your load balancer. And then we need to select the kube context. Now, the kube context, that's basically where it becomes interesting. This gives it the ability to share that cluster with a full group or with a project, for example. I've showed you how we can share it with a group. You can also specify specific projects. If you don't want to go that broad, it is also possible to define it or make it smaller, the scope of the agent. We define it then here in a pathway, and then afterwards we give the name that I gave the agent is EKS agent. In that case, we can configure it here as well. What it also gives is the ability is to have multiple agents. So for example, multiple agents on multiple clusters, but also multiple agents on a single cluster is also possible for whatever use cases. There's enough configuration parameters possible as well or available that we can create namespaces for each of the different projects so that we never get any clashes and potentially issues with the cluster. So we can have one cluster for multiple projects, for example. And all of the services can live there in harmony. Let's put it like that. If there's any questions, feel free to interrupt me as well, or write them in the chat. I'm happy to take them while we go. This is basically how we configure the agent and how we make Auto DevOps give the ability to deploy these review environments. Not just review though. So when I go back to my project here that I have running, which is my Node.js project right here, and I go to my pipelines, the last pipeline that I had on my master branch, we also have the ability in Auto DevOps to deploy to production. My case here, it does the same things when it comes to security scans or your tests. Still does all of the tests that we saw before. The only difference here is that it deploys to production. And when it deploys to production, again, it deploys to my cluster right here. Now, this can be configured, how that looks like. So if I go to my settings under CI/CD, there's actually an option per project that I can define if I would like to have Auto DevOps, first of all, enabled, yes or no. And then if it is enabled, I can then decide how do I want to deploy? Like what type of strategy do I want? Do I want to go directly to production, which I've selected here, quite aggressive, but works? Or do I want to have the ability to deploy and then have a timed incremental rollout? Or do I want to have, I deploy to staging, I first want to check everything myself, and then I manually want to deploy to production, for example. The last option is more popular in my experience. We can, however, or I can also show you later how we can build something like that or very similar on ourselves. So without using Auto DevOps, basically. Okay. Now, Auto DevOps, as I mentioned before, it's there when we are not using a GitLab template. But what actually happens if this full scan or this full pipeline that I have right here is a bit too much for me and I want to make some changes? Now, for that, we actually have some options as well. So what we can do is we can actually extend our Auto DevOps template. If I open up this template right here, we can actually see what we are loading. So basically what we do is we load this template when Auto DevOps is enabled on project level or on group level. We load this template and then use it basically to select what we should do with it. The first thing that you see here is that we have documented the different scans that I showed you before, the different security scans, especially, for example, the code quality one, takes an amount of time to finish. What we can do is we can disable these by setting these environment variables or basically variables. We can do that in two ways. Go to the project, go to the project CI/CD variables, add it there, and set it to be disabled. What we can also do is we can actually create our own CI/CD template and create these two parts. So we can include templates in our own CI/CD pipelines and then override variables in these pipelines or add variables, allowing us to select what scans that we want to execute and what scans we don't want to do. To give you a little bit of insights on what or how Auto DevOps actually does all of this, is we've created a template that uses workflow rules. These workflow rules then basically identify what is happening in this project. For example, if there's a Docker file, I know that we can do something with it. If there is, for example, Go file in there, we know that we can use the Go. We can use a build pack to build that Go application and then deploy it to as a single container to the Kubernetes cluster. This is also important to know. We're going to use build pack to package up your application and then push it on into a single container on the Kubernetes cluster for those review environments. When it comes to deploying, that's when we can then, of course, do different steps on how to deploy it to production. At the bottom, this is where we then include all the templates based on the different tests. And as you can see as well, and what I also show you here is that I include, for example, the full Auto DevOps template, but you don't have to. What you can also do is include different templates of the ones that you only need. For example, in your instance, we can do container scanning. We can also do SAS scanning, for example, in Premium. That means that I can create my own GitLab CI file and decide I still want those 2 security scans to run, and then everything else, all the other jobs, I will write myself. That's something that we can do, and I can also show you in a bit how that basically works like. That's the first thing that you can basically use to extend your GitLab or Auto DevOps function, is where we can go in with variables. But now let's go get started and actually make our own, how we normally see that our customers actually develop into a direction of writing their own pipelines. So I'm here in my project. And what we can do here is start with a new file. Right here under CI/CD, I can go to my editor and I can say configure my pipeline. Now, it automatically creates a template for me. And to be honest, the first things that it creates here is totally fine. Or what I can also do is basically, as I mentioned here, I can remove everything, just include my template there. And if I wanted to, then I can set also the variables to be there as well, to disable different scans if I would need it to. When I commit this, what will happen is it will still have the same pipeline as Auto DevOps, but in my case, my code quality will be disabled. So for example, if I commit here, we can see that's going to check the pipeline. And this is taking me too long, so I'm going to click here and go to my pipeline manually. You will see that the same pipeline is still being built, but you notice that the code quality one is missing. So we basically then no longer execute this scan. Now, you also saw in the template that we're using workflow rules. Workflow rules are for us also a very powerful tool that we can use to build our pipelines dynamically. What we can do in basically a template is that we write one template or write one larger file as we did in our Auto DevOps. And with these rules, make or have the pipeline execute specific jobs, yes or no. The typical one is, for example, when we have merge request pipelines. So for us, we differentiate between branch pipelines and merge request pipelines. What happens is if I push to a branch and there's no merge request connected to it, or the other way around, what happens if I have a merge request and I push to that feature branch that's linked to a merge request? If nothing is configured, we actually create 2 pipelines. We create one pipeline for the merge request and we create one for the feature branch, the branch request. To fix that, we actually have the ability to use workflow rules that only run it if it's a merge request event, or only run it if it's a commit to the feature branch. But if it's both, if it's actually committed to a feature branch that has a merge request attached to it, then we have this when keyword that says don't execute it. These type of things we can implement with rules and actually can build very powerful pipelines there, or dynamic pipelines. Same thing with templates there. We actually also have the ability to templatize these workflow rules. Workflow rules can be added on both the global level, I want to say, which is like the full pipeline, or we can also add them to specific jobs, for example. This then allows us to have specific jobs execute on, for example, I only want these jobs to run on the feature branch pipelines, but I don't want them to run on the merge request event, and the other way around. So we can have the flexibility of running specific pipelines, for example, also only on the main branch when we're doing a deployment to production. We want to create a full release, as you've seen before with semantic releases. This is basically with workflow rules, you can then create that dynamically. It can go even further, and this is what I will show you in a bit as well, is how we can use multi-project pipelines. But first, let's step through this here. There's a couple of other things that I think are also important to bring up, or that I can show you, is that the ability to have the when filter on your rules with a when manual tag. This is exactly what we saw before in Auto DevOps, where I deploy to production. We can have the ability to have a specific job stop and request for me to click on the little play button before it actually deploys. Helps me to do manual approvals. At the same time, I can have a better feeling of first test the environment before I can actually deploy it, for example, to another environment. One other thing that we have is the allow failure keyword. So by default, when a job fails, the pipeline fails. There is going to be a time, however, where we say this step is important and I would like to have the results, but it doesn't have to break my full pipeline. We then have the ability to say that a failure is allowed. And this will not fail the pipeline. You would still have the information there, though. So it will then be marked as little orange tick box that this test failed, but the pipeline itself will finish and continue and will not block your merge request, for example. Any questions about that here? If not, then I will show you how that would normally look like in another project here. So I've basically created an empty GitLab CI file here that just has the default stages in here, nothing special, basically. One of the things that I want to do is when I do a deploy to production in my case here, I only want to do that, for example, when we have our CI variables set to the default branch. So what I can do is in my way is that I can copy here. If the target branch name here is the default branch, just copy this here. So in that case, if I deploy to, in my case, production here, if we're deploying to the default branch, which is the main branch, then I want this step to be manual. I don't want it to allow it to be failed, of course, but I can have this step then to be manual. When I push this, continue, you will see that I'm actually pushing to the default branch, which will then immediately show me as well in the pipeline this new change that I've made. It's not being picked up because it's not okay, because I'm using the wrong variable here. There we go. Because I'm not doing a merge request, of course. Yes. So when I would now create a merge request on this here, so let me quickly create that. And in this merge request, I'll make a quick change. Example in the README file. Minute. Go to my merge request. You see that a merge request trigger has been triggered, and you can see immediately as well that because of these rules, I'll now have this job available, but it has to be manual. So I basically only have the ability to then manually deploy it. These type of rules then basically on job level allow me to specify which jobs I want to run and which ones I don't, but also build these type of manual workflows basically. Now, it's really cool to have this, right? I think the last thing that I want to show you is how a multi-project pipeline can look like. What we can do, namely, is we can execute a pipeline in a different project. So for example, I've created this right here. If I go into my editor, just remove this and replace it. I'll just quickly run over what we're doing here. We're creating an artifact here, basically allowing me to store some files in here. But what we can actually do is we can give this artifact to a next project, for example, or a next pipeline. In that next pipeline, in a different project, I can then retrieve that artifact and do other actions with it. So I can move different libraries or different binaries between different projects if I would like to. This one is actually now going to trigger a project that I actually don't want to trigger. So we're going to do it like that. It triggers twice. And as you can see as well, we are going to give some variables with it that then allow us on the other side, if we would like to, we can read those variables. So anything we pass through here, we will be able to see. So if I commit these changes, you'll see that a new pipeline will be kicked off. And if I go in here, it shows you that little downstream icon here that you can see. And the thing is as well that we can see the status of that pipeline. And we can also monitor it, what it actually is doing. So in a single view, I have all of my pipelines in here. I don't have to switch to the different project and see the pipeline, what it's doing there. I can actually see here as well what's going on. And I can see which job triggered the downstream pipeline in my case. It's possible to configure how downstream pipelines work in more detail, especially if you want to, when it actually succeeds. So if you want this pipeline to stay on pending or running while the downstream is still running. Yeah, thank you. I knew that. And it failed. Or if I would like to have it as long as from the moment it hands it off, that it then says, okay, this pipeline is ready, everything fine. That's something that we can configure as well. I see I have 2 minutes left. And this is also the main things that I wanted to show. So I want to open up the floor for any questions you might have. Doesn't have to be immediately around these pipelines, but if you do have questions, then please go ahead. Okay, then I'll hand off back to Gert. Or someone who can then close up.
Yeah, I think these were very interesting sessions for 3 topics that were very interesting. Yeah, Niha, I think we have to end it here now because the time is up. Yeah, we at Mediahuis, we are already looking forward to the next session in the future.
Thank you for that, Gert. And thank you everyone for your time. You would have all received your lunch vouchers. Please feel free to, order your lunch and have it. As next steps, you will all receive, the recording of the session as well as the presentation. So in case, you have missed it or you would like to, ask any follow-up questions, maybe not now over the email, please feel free to do that. And we'll try to, get those answers to you as soon as possible. We are, now hosting our next event. That's AWS Summit. We are participating there. And in case that's in Amsterdam on 1st of June. So in case if you all are attending, we are at stand, B15. Feel free to drop by and we'll be happy to meet you. And, if you have any questions, we'll be happy to answer those in person. And yeah, do feel free to let us know what we would like to learn next. Is there any particular topic that you want us to cover? Any feedback in terms of how interactive, can we make them more interactive? Should we increase the length? Maybe we should add more hands-on experience. Do let us know those feedbacks, and we'll be happy to incorporate all of those in our next session. Thank you everyone for your time, and you all have a good day. Thank you everyone.
Thank you.
Bye-bye.
Very much.
Bye.